Okay, hello everyone. I'm Miguel Grinberg. I am a principal software engineer with Elastic. You have my Twitter or elephant thing uh, in case you're interested. So there we go. So I work in the developer tools team at Elastic. This is the team that produces the language clients, among other things. So I am not a machine learning specialist, disclaimer. And I don't have a lot of time because I don't want to run out of time. So I wrote a bunch of books. You can find them on Amazon. I maintain a bunch of open source projects. You can find them on GitHub. And then I have a blog if you're interested, mostly about Python. Feel free to check it out if you haven't seen it yet. So what are we doing today? So I'm in a live code. So if you're not a developer, I apologize. This might be a little bit boring. So what I have is I wrote a skeleton app that is a React app with a fast API backend, and it doesn't have a database. So we're going to add a database right here and now. So the things that you're going to learn, I'm going to show you how to run Elasticsearch for free, unlimited, no no licensing or anything. You can run it for free. I'm going to show you how to use the Elasticsearch-DSL client. This is one of the two Python clients that we have, and it's the one that I'm maintaining myself lately. Sometimes we call it the high-level Python client. It's probably the Python client that you don't know. If you know one, it's the other one. And so I'm going to show you how to ingest and search documents, including vector search. And then unrelated to Elastic, I'm going to show you how to generate vector embeddings in a way that it's very easy to play with for free on your computer using this sentence transformers model, in case you've never used it before. So yeah, that's pretty much it. So I have a repo if you want to go there. And while I was practicing for this presentation, I completed the application. So I'm going to write some code that you will see there that I'm not going to have here on my laptop right now. But then later, if you want to review it, you can look at there. If I run out of time, which is quite possible, then you'll have the code there to play with. So this is my terminal. I have so these two are the front end and the back end, or the reverse back end at the top right front end. So they're programmed to restart when I change the code. So I'm not going to touch them. They're there. They're running, and this is the application right now. Doesn't have anything because there's no database. So the first thing that I'm going to do is I'm going to show you how to run Elasticsearch. This is I'm not sure why. It's difficult. Maybe a reason is that there's like 19 different ways to run Elasticsearch, all documented on our documentation. So I'm going to show you one that is very easy to do on your machine if you have Docker, and if you want to play with it with no commitment. So it's basically a simple way. It doesn't use, it's not secure, so it's not definitely something that you should do on production, but proper for development. So I'm sorry, wrong side. On this side, this is the repository that I just sent you to. So here I'm going to find, this is the Docker run that you can use. So just one command and you can get Elasticsearch up and running. So, okay, that was easy, right? So now you have your very own Elasticsearch service running. We can check just for fun that it's running. Elasticsearch runs on port 9200 by default. So you get a response. It's a web service, right? So JSON responses. So we're good. We're good to go. So, okay. The project has, as I said, a fast API backend. I'm going to go into that directory here. And here I have the API, which I'm not going to discuss. That is the skeleton thing that I mentioned before. And then there's search. I installed the requirements, by the way. I don't know. I don't want to waste time with that. You can do it if you try the project yourself. But I've done it here already. So my search.py is mostly empty. The only thing that I have here is the sentence transformer model, because I always forget that name. So I didn't want to have to remember that or memorize it. So that's the model that we're going to use to generate embeddings for this project. The database is going to have famous quotes. And I have, it's right here in this directory, in the backend directory. This is a data set that I found on Kaggle. I changed it a little bit, but it's basically 3 fields, a quote, the author of the quote, and then a string with comma-separated tags. Pretty standard, right? So that's the data set. So what I'm going to do first is I'm going to show you how to make a connection to Elasticsearch using the DSL client. This is this DSL, Elasticsearch-DSL package. That's the high-level client that I'm going to use. So one thing that it does that's different from the client that you probably know is that it has the concept of default connections. So I can create a connection and then I don't have to worry about connections. It always uses that connection. So I'm going to write one line. So this is going to be an async application. There's an equivalent way to do everything I'm going to do today that is not async. Like if you're using, I don't know, some random framework, Flask. I don't know, I'm just coming up with random frameworks. You can do the same thing pretty much there. But so today we're going to do everything async. So I'm going to create a connection, and post is, and here I can pass a list, right? Because this is it could be distributed. Right now I'm running one node, but it could be multiple ones. So localhost 9200, right? So that's it. That gives me a connection. So I'm not going to worry about this anymore. Anything I do in this file, it's going to be using this connection. So next, I'm going to define the data model. So this DSL client for Elasticsearch works in a very Pythonic way. So what we're going to do is we're going to create something that is close. If you're familiar with data classes, this works pretty much like it. So it's not a data class, but it works like a data class. Create a quote document, and this is going to inherit from the async document. As I said before, there's a non-async document as well if you want to use regular Python. And here we have quote, which is a string. We have author, which is a string. We have tags, which is a list of strings. And then we are going to add embeddings, right? So we have an embedding, which is a list of floats, right? Pretty standard, So when I define fields like this, the default for this client is to index each field that is a string in using an inverted index, the famous thing that Elasticsearch has been doing for like forever, right? To do full text search, right? I'm going to leave that on the quote field because if we get time, I'm going to show you how to compare vector search with full text search. Not sure if we're going to have time, but I'll leave it there just in case. For the author, it doesn't make sense. So here, in a way that is also very similar to data classes, I'm going to override the default definition of this field. And this is going to be a keyword field. And those who have used Elasticsearch know what this is. This is basically a string that is not processed for full text search, right? So it's more efficient, takes less time, and all of that. And then same thing for the tags. The tags are also strings that don't need to be processed. And finally, the embedding is going to be a dense vector, which is another native type of Elasticsearch these days. Then what I'm going to do, and if you're familiar with data classes, you know what this is. I'm going to tell this class that I don't want to worry about the embedding field when I'm working with the class. And the reason I don't want to have to, at the application level, worry about it is that I'm going to automatically add the embedding when I'm saving these documents, right? And the way that this client allows you to do that is by defining a function that I don't really like this name, but it's been like this for years. It's called clean. It's supposed to do, you're supposed to do validation here, but you can also write add fields that are not originally in the document. So here, what we're going to do is, if not self-embedding is, and here you can see how easy it is to generate an embedding with sentence transformers. Model.encode, and then self quote, right? So this gives us an embedding. This comes as a NumPy array or vector, whatever they call it. And we need a list. So we're going to make it a list. That's it. Okay. Another thing I need, is to name the index. So in Elasticsearch, a database is called an index. So we need a name for it. You can have multiple indexes or indices, as they like to call them. So for that, you do it like this. So now we have an index. So that's the data definition. That's the way it works. I quite like it. This is fairly new. I'm using a pre-release of the DSL client for this, by the way. It's coming out in 2-3 weeks. And if you use the requirements file that I have here, you're going to be using also the same pre-release until it gets released. And the pre-release, I did a lot of work myself on getting the types to be agreeing with Python. So this is all being type checked right now, right? So yeah, if I mess up, you're going to see the errors here. So that's the main reason I'm using the pre-release. I want to make sure that, to stay honest. So, okay, let's keep moving. So I'm going to create the index. That's the next step. So first of all, I think I'm going to be running this a few times until I get it right. So if await document index exists, I'm going to delete it before I start. I'm going to running a few times until I get it right. So, okay. And then to initialize the index is quote though init. Okay. So that creates an index. So I'm not sure if it's clear. This creates the index, it creates the mappings. If you know what those are, it will define all the fields, and we'll take all the fields as I define them in Python and convert them to Elasticsearch, right? So all of that is done. So next step is to read that CSV file and get the thing in the database, in the index, right? So this, I'm going to use the CSV package from Python, standard thing. So I'm going to open the file, and then I'm going to create this reader object, which is the reader, passing the handle of the file. And now I can do for row in reader. And now each row is going to be a dictionary, and it's going to have the names of the keys are coming from the first line in the CSV file, right? So here I can do quote doc. And then, oh, by the way, note it knows all the types. I'm so proud of this. I did myself, by the way. Right, and the one that I omitted, the embedding, doesn't even show. So, yeah, I'm happy about this. Sorry. Okay, so quote, row, quote. Author is row author, and then we have tags is row tags, but this is a string and we need a list. So we're gonna split on the commas, right? So that's document, and then save it. Okay, simple enough, right? So this is the simplest way, the beginner way to ingest data into an Elasticsearch index using the DSL client. So before I run this, I'm very conscious of performance. So I'm gonna, if you excuse me, I'm going to write a very quick ingest progress function when I pass how many we ingested and the start time. And we can calculate the elapsed time, right? Like that. So this is how much time from the start in seconds. And then ingested count quotes. And this is going to be what? Count / elapsed, right? Per second. Just so we have an idea. And actually, this is gonna be a decimal, so skip the decimal. So let's use this. So I'm gonna have a counter, start time, and then here, let's say every 100, we're going to call the ingest progress. And we pass count and start. Okay. Okay. So yeah, just give it a try, see what happens. I'm sorry. Oh, yeah. There you go. Thanks. Right. So count should be, thank you. So you see, that's why I'm deleting the index each time I'm running this, right? Because that starts me from a clean slate. So let's see if this works, please. Right, there you go. So it's chugging along. So this CSV file has close to 37,000 quotes. So I don't have time for this, right? So this is nice. It's simple, but normally you will only do this if you're playing, right? You will never do this for real, right? So one way that Elasticsearch is famous for is having bulk ingest solutions, right? So this client also supports that. So what we can do here is we can convert this little portion, the portion that has the loop and the reading of the CSV file into a generator. Next quote. So like that. And then instead of saving it, we're just going to yield it. And then here at the bottom, I can say bulk. Get next quote. And this is going to run a little bit faster. And if anyone can guess why this is not going to be a lot faster, feel free to chime in. Not, I'll tell you. But yeah, it's running a tiny bit faster, but still not good enough. Any ideas? No. Okay, so I'll tell you. I could change it, but it has defaults that are decent. So it is actually working. That is working fine. It's bulking. Okay, you're the winner. Right. So we are creating an embedding for each document, right? This is the. I'm going to stop this. Right. We're not going to do this anyway. That wasn't your question. Okay, I take it back. You're not the winner. I'm the winner then. Yes. Oh yeah. That I did this at the beginning. It's line 22. Oh, okay. Yeah. So the problem is that we are automatically, right? The first option that I used and the bulk option, both are calling this clean function for every document, right? So each one needs an embedding, and embeddings they need to be calculated. They use the GPU, and in this case, because of the way I'm doing it, it's using the GPU serially, right? It's running one embedding per document. So this machine does have a GPU. So what we could do to really make it fly is to parallelize the embeddings, right? So this clean function is convenient, but not best for performance. So what I'm going to do is I'm going to make this a raw quote generator, and then I'm going to write a helper function here, embed quotes. Oops. You can tell I'm not used to type on this, on the laptop keyboard. So this is going to take a list of quotes. And here we can say embeddings, model, encode. And here we can pass quote for Q in quotes, right? So we get all the quotes, all the quotes, all the strings from the documents. We pass them, all of them in a simple operation. And then this is going to go to the GPU, and PyTorch, or whatever this is running on, is going to do its thing, right? And then what we can do, and this is going to be a little bit of Python magic, maybe for some of you. So what I'm going to do here is for Q and E in zip quotes embeddings. Do you know what this does? This basically, it takes two lists. So I have a list of quotes, and now I have a list of embeddings. And I want to iterate on all of them, and get one of each, the pairs, right? So this does this, right? So Q and E are going to be, first the first element of both lists, then the second, and so on, right? So now I can say Q embedding equals to E to list, right? Remember that I need to, this is still a NumPy, it's an array of NumPy arrays. So I need to make them into Python lists. So, and then I can yield from this one the now assembled quotes. So down here, I'm gonna write yet another iterator. This is going to be the new version of get next quote. And here I'm going to make a list. And then I'm going to get quotes from the raw iterator. And just put them in the list, right? And then if I get, and this is I experimented with this. I tried different numbers, and I found that sending 512 kind of works. On a different machine with a different GPU, it's going to be different. If you don't have a GPU, none of this makes sense, right? You're toast, right? So what I'm doing here is, right, I'm grabbing quotes from the CSV file. When I get to 512, I have them all in a list. So now I'm going to use the auxiliary function so that I can get the embeddings of all of them in a single operation using the GPU. Does that make sense? No, the GPU's been used from the beginning. That's default. This model, if it finds the GPU, it uses it. So, we're using it, but we're not using it in the best way, right? We need to parallelize. So yeah, so we have here now 512 quotes. So what we can do is embed quotes, and these double Q are going to come with the embedding, and they're going to be generated very efficiently. And now we can yield the double Q. And then when we're done with the 512, we can clear the array, and this is going to continue and get the next 512. That makes sense? So I'm going to change this progress thing to be aligned with the 512 as well, so that they happen at the same time. I get a chunk. And then the last thing I'm going to do is at the end, this is unlikely to be a multiple of 512. So I'm going to, if I get more than 0 when the iteration ends, I yield those as well, right? So that I get all of them, right? Okay. I have some errors, of course. So this is why I'm using the typed version of the pre-release, so that I find all the mistakes. So this needs to be async. This needs to be async. This needs to be async. Oops. What's wrong with embed quotes here? Yeah. Typo. Okay, all clean, right? Yeah. So fingers crossed. And you can see now this is kind of working its way. So my test, it gets to close to 500 a second. So this is going to take like a minute and a half, and we're going to have the 37,000 quotes in the database. You have a question while we wait? Yes. What part? So the model basically takes a string and returns an embedding for the string, right? It looks at all the words that are in that string and calculates the embedding. So what we're doing here is we're sending a list of strings, and we get a list of embeddings. That's basically right. The GPU can do this. It can generate multiple embeddings at the same time in parallel. The GPU does it. Or sentence transformers, the model that I'm using, right? So it's almost there. It's running a little bit slower now. Well, I decided to try it myself and see if it worked. And on this GPU, it makes a big difference. So yeah, go ahead. Okay, so I started with, so I know that the model itself creates batches of 32, and then it processes 32 by 32. So I started with 32, and then I said, probably if I send 64, if the model is still doing 32, it's not going to change, but it did change, right? So it ran faster. So okay, let's try 128, and I kept going, and 512 is where I started. I stopped seeing benefits if I went higher, right? It could be completely different on a different machine. I have no idea, right? I don't know what I'm doing, right? As I said, I'm not a machine learning specialist, right? But anyway, we have our almost 37,000 quotes in the index, right? What time is it? Yeah, we're doing good. There's hope. Okay, so we have the index, and the fast API backend will call, or actually already calls, this search quotes function to get quotes, right? So I implemented all the pagination, all the things that are unrelated, right? We're not talking about all of that, but if you're curious and you want to learn, the source code is there. Feel free to look at it, right? But I implemented this, right? I'm a software engineer, right? This is what I do. I love doing this. Well, Elastic provides Elasticsearch, right? It's the index. So that's the focus of this exercise, right? So it's going to call this function. The Q argument is going to be whatever you want to search for, or it could be empty if you're not searching yet. Tags are going to be if you have a filter, you're going to see only certain tags. And then if we have time, we can try switching between vector search and full text search, and then pagination numbers, right? And then it returns three things: the list of documents that that respond to that search request, the aggregation of the tags, so that you know how many of each tag there are within those results, and then finally the total number of results. So those are the three things. So start from the beginning. It's super easy thing to do. So I'm going to get a search object. This is going to be, it comes from the quote document, right? So this is already prepared to search this index, right? It knows everything about it, right? So the very first thing that we can do is to get all the results. So this is a very simple query. So queries each time you add a query, you get a new search object that is, expanded. So S equals S query. And here, I'm going to use this query match all, right? This is part of the traditional Elasticsearch, range of queries. This one returns everything, no questions asked, right? So this is the one that we're going to do first. And then to run the query, I can say response equals await execute, S execute. So this is going to run the query. By default, Elasticsearch returns 10 results. I don't know if you know, this is a default. But here we do know how many results we need, right? A default of 25 or whatever the client wants, right? So that works using the array syntax in Python. So we can say that we want from result start to result start plus size. And this takes care of the pagination. Yeah, makes sense? And then what we can do here is return our hits. That's going to be a list of quote doc objects that satisfy the search, which in this case is everything, right? By the way, right? So we're not searching yet. Oops, sorry. And just to make sure that this is working, I'm going to refresh here and pray that I get a result. There you go. So the quotes are now coming, right? So you see the scores, which is the way Elasticsearch, assigns a relevance value. They're all one because we're not searching, right? That this isn't a search, right? So yeah, we still have no tags though, right? The first 25. So there's no query. It's keeping all of them in order, right? So, oh, actually, I have a bug. There's no pagination here. I don't know what happened. I was messing with this before the presentation. I think I broke the pagination. So we're going to ignore that. I'll fix it after this. So the total is 0, right? That's the third number in the list of results. So let's fix that. So this guy is going to be this. This is one that unfortunately I think it's a bit obscure the way you have to get it. And this will make sense to you if you've used Elasticsearch responses, right? This is documented. This is the way the JSON object comes back to you. I need to find a way to make this work better with this client, which is supposed to be high level. This is not very high level, right? So definitely something I need to work on. But yeah, now. And now we get 10,000. 10,000 is the maximum by default. Elasticsearch does not return more than 10,000 results. By default, you can change it, but this is the default. So yeah, actually, yeah, now I get pagination. It didn't work before because it didn't know the total. Right, there you go. Phew. So now I can get to the next page and I get 26 to 50 and keep going if I want to. And then I can go back to the beginning. Right? So this is looking good. And I still have a few minutes. So let's do the search. So here what I'm going to do is, if Q is empty, we're going to keep doing this, right? This is actually the correct thing to do when we are not searching, right? We don't know what to search for. And then if not, we're going to do a different one. And out of the vast array of different queries, there's one called KNN, which means K nearest neighbor, right? You probably, all of you know this from before I knew about this, right? So this is going to, technically this is called approximate KNN. It's not an exact KNN. It's a performance conscious KNN. It may not give you the exact results, all the results, but it's going to do the best it can to find relevant results. So I need to fix this, by the way, too. It's very confusing. So this guy takes a field. So the field that we're going to search on is the embedding field that I added. And then we need to pass a vector, right? The vector that we are going to search, that's going to be compared against all the vectors that we have in the database, and then we're going to get the closest ones. And the query vector is going to be coming from the model. So model encode Q to list, right? Like that. And that gives us search, hopefully. I'm going to refresh just for, okay. Right, so yeah, we're searching bananas and we get, yeah, the first one is about bananas. The second one's about fruit. Well, it's about fruit. So, this is vectors, right? So, right, so, yeah, banana pudding. My favorite, I think, of all the ones I've seen while working on this data set, time flies like an arrow, fruit flies like a banana. Love that one. So anyway, it sort of got the gist. It's about fruit and it's doing its best, right, to find things about fruit, not only bananas, right? So what we can do, So we can use this when useKNN is enabled, and then we can add the other one, which is the old school Elasticsearch, full text search, right? Just for fun, and that one is called match. You have seen this, and for match, you do it like this, quote. So this is the field name equals, and then the search criteria, right? So like that. So now here, if I remove, so that button there is the one that toggles that useKNN. So here you see there's only one document in the whole thing, in the 37,000, that has the word bananas, right? Banana singular does not, it's not finding it. Now, Elasticsearch has a boatload of things that you can do to improve this. You can define synonyms, plurals, right? But the vector search doesn't need any of that, and it gets us results that are quite good, right? Well, what was the other one I tried? Political corruption, I think it was one that I tried. And this one finds either things about that have the word political or the word corruption, but it never makes any sense, right? And then the other one, it's kind of talking about politicians and criminals. I think I saw somewhere. So yeah. So anyway, so these are the search options, and the thing that we're missing is the tags, which I'm going to try to add. And this is an area that I believe Elasticsearch shines compared to competitors, maybe newer competitors that only entered when there was the Gen AI revolution, right? Because so with Elasticsearch, you get a database, and the standard things that you do with a database, for example, aggregations, which they're well integrated. So what I can do here now is say there's one type of aggregation called the bucket aggregation, which basically counts and puts things in buckets and then gives you the size of each bucket, right? That's what we're going to do. So so this, and we're going to name it tags, and then the aggregation is going to be DSL tags terms. So we're going to look at terms, right? The tags are terms. And then the field is tags. And I believe that's it. And then after this, we can get the tag counts in the response in the R object. And this has, I believe, buckets. And here we can do a list comprehension and get the pairs of tag name and counts. Tag key, tag count. Surprised I haven't messed up yet. At least not in a big way. And then this is going to be the second result. Let's see if that works. Right, so now we have some tags. And the default for tags is also 10, which is kind of low for this. So I'm going to change it. Let's do 100. Right, so now we have the tags. And the front end is actually allows you to select tags, and this is supposed to filter, but I haven't done the filters. So let's do the filters, and then we'll call it done. And for the filters comes in that tags argument that I haven't used yet, right? So for tag in tags, s equals s filter, and the filter is going to be a terms filter once again, because we're filtering words. And this is going to be tags, and I'm going to pass the tag as a filter. Okay. So now, say we search for bananas. So something that's interesting, bananas, there's 38 results. The aggregations that you see there are for the 38, not for the 25. Okay, so this is working like a proper database and it's giving you the aggregations that you can use, you know, and not just for the section that you are viewing, right? And then I don't know if you want to see bananas and love, you know, those are the 8, and out of those, if you're gonna see the ones that are about bananas with love and hope, then there's 5, and you know, that's the way it goes. So yeah, I think I'm going to end it there, and if there is time, which I think there is, I can take questions. Okay. Sorry, so in the same line. Okay, yeah, go ahead. Yes, so are you asking me? Well, they pay my salary, right? That's the main advantage. I cannot be fair, right? To be honest, I don't use the other ones, and this is the first time I work with search. I actually wrote. Some of you might know this. I wrote a tutorial that is very famous for Flask ages ago, and I used Elasticsearch, and that's what got me this job, in a way, right? But yeah, I don't really, you know, I don't do a lot of machine learning myself. Well, of course, that goes back to what I'm saying. This is a database that has, you know, years of, you know, robustness, and all of that is integrated now with vector search. Okay, well, there you go. So you had a question too, the same line. I have not compared, well, no to both. So I haven't done that because luckily that's not my job. Right. So I'm mostly interested in making this experience, you know, allowing developers to write the code in the best possible way, and that's what I'm working on. So yeah, unfortunately, I think Elastic would think I'm wasting my time if I spend time on that, right? Because you know there's other people that do it, and yeah, they will do it much better than me. Yes. How does it integrate? Right. Well, this is Elasticsearch, right? You get everything, and if you look at this, I am integrating, so match all, match, and the aggregations, for example, those have been available in Elasticsearch for years before anybody was talking about vectors or embeddings or Gen AI, and now you know it's integrated, right? Because there's this query framework, the query DSL that we call it, and when we add all these new Gen AI features, they get inserted into the same framework. Yes. Uh, yeah, do the best I can. I'm not sure I understand V2s. Oh, videos. Oh, videos. I'm sorry. Videos. Yeah, you will. Yeah, you will. So as a developer, I'm thinking you have two options, right? You either generate embeddings locally or remotely, right? So if there's probably going to be a service that will give you the embeddings, right? That you upload the videos to and provide the embeddings. Yeah, I probably wouldn't do it locally like I'm doing here in that case. And then if you are interested into the offerings that Elastic have, Elastic has a cloud offering, right? That might work for this. Depends on the model, right? How the model's trained, right? It really depends on the model, right? The model will take an input, and if the input is the video itself, then yes, yeah. Mhm. Persistence. Okay, but this is persistent. What do you mean? Well, so yes, the way I have this here, so this is the Docker container, and oops, did I not? Hold on, right. So you see the dash V, right? That basically persists the data directly in the container, right? So if you're doing this in production, you will not do this, right? You will probably use a Docker Compose file, I would imagine, or Kubernetes, right? We provide scripts for both, and yeah, you will use a Docker volume, right? I will think. Mm-hmm. Yes. Thank you so much.